Hello all. In today's session we will implement CNN model. We will be designing a CNN model to classify multi-category TIFF images using TensorFlow and Keras. So this TIFF represents tagged image file format. All the images what we have studied previously are in either JPEG or PNG formats. So we will either use datasets which has images of TIFF format .tiff, or we will convert JPEG or PNG images into TIFF. So here I am using Ciffer10 dataset which has PNG images, that is portable network graphics, that I will convert it by importing necessary libraries into .tiff files. So you can see here, first I am importing all the libraries here, importing the operating systems, and then TensorFlow. I'll import the Ciffer10 dataset. Next, from PIL, I will import the image. PIL is nothing but Python image library which is used for image pre-processing. Here it is used to convert the NumPy arrays into images which will be stored in .tiff files. Next, I will be creating the directories to save the images. This is for training and this is for testing directory, and then I will load the Ciffer10 dataset. Different labels are defined here. These are 10 labels which are present in Ciffer10 dataset. Next, I will use a helper function to save all the images of Ciffer10 dataset in .tiff format. So I will be defining a function which will store the images in .tiff format, and for every iteration all the images of all the labels will be, it will go through all the images. That is, it will iterate through each image and its corresponding label. Next, it will convert array to PIL image. This is the label what we are defining here. That is labeling 0, for example, labeling 0 for airplane, labeling 1 for automobile, and so on. This is the command used. Then I'll create a subdirectory for each class, and this is the command to save the images in .tiff format. So once you run this, you will print images have been successfully saved as .tiff files. Next, after converting Ciffer10 into .tiff files, you can load these .tiff images and use CNN to classify them. So these are the necessary libraries what I am importing. So here we'll be importing image data generator also. These are the different directories defined which for training and testing data. Next, we will define image data generator with the data augmentation for the training set. So this data image generator, what will it do is it will create a data generator that will pre-process the image. Like you can see in the first case, it is normalizing, rotating randomly to 15 degrees, shifting the width, and so on. These are the pre-processing steps that are carried out using the function called as image data generator. Next, this is for testing. Load the training data, load validation data, and load testing data. Out of 60,000 images, 40,000 images are used for training, 10,000 for testing, and 10,000 for validation. Next, once we are ready with our images in .tiff format, we will build a CNN model. So here you can see I am using 3 convolutional layers followed by max pooling and dropout layers. You can skip this dropout also and check the accuracy of the model. If you find that there is validation, the model is performing very well on the training data but is failing in performance with the validation data, then you can introduce either early stopping or dropout layer. So initially only I have used dropout. 25% of the neurons will be dropped here. 3 convolutional layers, and next I'll have a 10 neurons in the dense layer as we have 10 classes. Then I'll compile the model using Atom Optimizer, and the loss function what I'm using here is categorical cross entropy. So when you print the model summary, you can see here these are the number of parameters, total parameters. You can see these are the trainable parameters. Next step involved is train the model with early stopping. So I'm using here early stopping here to reduce overfitting of the model, and number of epochs what I'm using here is 10. The steps and the procedure, everything is same as what we have discussed in the previous CNN model designing for classification of images. The only difference is we have converted PNG images to .tiff images using certain libraries here, that is PIL directory, Python image library directory we have used to convert those images into .tiff format. Next we are evaluating the data, test data, plotting the training history. This is the command, and what you notice here is this is the output of training and validation accuracy to the left side, and this is training and validation loss. You can see that the loss is reducing as the number of epochs are increasing, that is the model has learned well. And this is next making the predictions, and the accuracy what I have got is 64%. We can increase the accuracy by either increasing the number of epochs, or you can use batch normalization. We have different methods to avoid or to increase the accuracy of the model. So this is how CNN model with 3 layers. You can either increase the number of layers also. This is how CNN model is used, and to classify the images of .tiff files. Thank you all.